Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I'll look forward to seeing you inside the video.
Hi, this is the second video in the series where we're looking at the May or the June 2020 series for Edexcel, and it's the higher tier for maths. And the previous video we completed through to question number 10. In this video we're going to start from question number 11 onwards. Okay, so here we are at question number 11. Now the easiest way of dealing with these sorts of questions is actually to split up the two numbers that we've got there. We've got 81 and then we've also got 10 to the power of 8. So what I'm going to do is I'm going to say, well, I want the fourth root of 81, and that's fairly straightforward. There's actually 3, because 3 times 3 times 3 times 3 is 81. And then I've got 10 to the power of 8. And that's multiplied by, I can write the fourth root as the power of a quarter. So 10 to the power of 8 to the power of a quarter is going to give me 10 to the power of 2. And when I then take away the standard form, I can write that as 300, and that would be the answer to question part 11a. Okay, hopefully that's okay for you. Let's move on then to part B, which is a negative index. Now every time you see a negative index, it means the reciprocal. So it's 1 over 64 to the power of a half. The power of a half is really meaning the square root of 64, so it's 1 over 8, because 8 is the square root, and that would be the answer for 2 marks to part B. Okay, let's move on then to part C. This one's a little bit trickier because effectively we've got 9 at the bottom. So what I'm going to do is I'm going to rewrite that 9 as 3 to the power of 2. And then that's the power of n minus 1. Okay, so let's have a look at what happens then. Well, I've got 3 to the power of n as the numerator. The denominator I need to multiply out, so I get 3 to the power of 2n minus 2. Okay, now when we're dividing, which we are effectively with this fraction, we need to subtract the powers. So therefore I'm going to get 3 to the power of n minus, and be very careful here, it's going to be 2n minus 2. Now I've put that into brackets because effectively that will mean that the negative 2 there becomes a positive. You'll see what I mean in a minute. I get 3 to the power of n, and then I've got minus 2n, and then minus multiplied by minus is going to be positive, so it's positive 2. Okay, that gives us then n minus 2n is going to be minus n plus 2. It's not very neat to write it that way, so I would write it as 3 to the power of 2 minus n, and that would be the answer to part C. So a little bit trickier to deal with, but hopefully that was okay. With all of these videos, please do stop the video, have a go at each of the questions. If you're not sure about anything, let me know in the comments, and I might have a playlist or some other materials you can have a look at. Okay, so question number 12 is a cumulative frequency. Fairly straightforward, working out the cumulative frequency. Now, it's going to be a little bit difficult on the screen to show you, but hopefully you'll be able to work out that what I'm doing is I'm just adding the accumulation of the frequencies which are in the top table here. Okay, so please do stop the video, have a go at these questions for yourself, or visit 3 Minute Maths and print off the worksheet, the exam paper, and that will give you the ability to work through each of the questions and then compare your solutions. Okay, so we've got the cumulative frequency there, and it says on the grid opposite, draw a cumulative frequency diagram for your completed table. So I'm afraid it's going to be a little bit of backwards and forwards, but basically with cumulative frequency diagrams I'm going to plot the end of the class width, which is going to be 250, to the value of the cumulative frequency, which is 5, 300 to 15, 350 to 35, and so on. So when I go through to the actual grid itself, here it is. it gives me the ability then to plot each of these points. So I'm going to do this very briefly and quickly on the screen. It might not be exactly right, but hopefully it'll give you some idea of what these will end up looking like. So it's 352, 35, and what you generally tend to get with cumulative frequency is a very nice kind of slope. It's a bit like a ski slope, I think. So that's going to be 452.70, which is, is going to be here, okay. And then finally I've got 500 to 80, which is going to be at the top here, okay. And when I put all of this together, it's a little bit trickier on this particular video, but it's going to look something like that. I wish I had the ability to zoom in on these, but unfortunately I can't. But hopefully that will give you some idea. Okay, so part C of the question, 60% of this group have a weekly wage of £360 or less. Is one correct? So what we need to do is go back to the cumulative frequency diagram and look at £360, which is going to be here. So once I take that up to the actual graph itself and then take it across, now unfortunately it's not a fantastic drawing here, but it basically works out at 40 as the cumulative frequency. So let's have a look at what one is saying. 60% of the group, well, it's actually 40 out of 80 in the group, which is equal to 50%. So I'm afraid in this particular case one is not correct. So I'm just basically taking the information directly from the cumulative frequency diagram. Okay, hopefully that's okay. There is a worksheet on cumulative frequency diagrams if you'd like to practice these a little bit more. Let's move on then to part 13 of this particular paper, and this is a density one, very popular, and really it's just a case of applying the formula. So if we look at liquid A, well, we can write that density equals mass divided by volume, and I would try to encourage you to make sure you always write the formula. I keep saying this on all of my videos. It's important to write the formula every single one. So I've got a density of 70, which I've taken directly from the information there. The mass I've also got is 1400 directly from the information, so it allows me then to work out the volume. And really effectively I would just swap over the volume with the 70, so therefore I can work out the volume equals 1400 divided by 70, and that's going to give me a volume of 20 meters cubed, and that's fine for liquid A. Let's look at liquid B. Okay, and again I'm going to write out the formula, and I'll just write it as density equals mass over volume. Okay, and what information have we got about liquid B? Well, we know the density is 280 because it gives it in the information. The mass is what we're looking to achieve with this one because we know the volume is going to be 30. So therefore the mass of liquid B is going to be 30 times 280, which is 8,400 kilograms. Okay, so we've got bits of information now, and then we can look at working out the density of liquid C, which is the question itself. So the density equals mass over volume. Okay, now you'll notice at this point I've written this formula 3 times. It just helps me to remember it every single time. So the mass of liquid C, well, that's going to be the mass of liquid A, which we know is 1400, and the mass of liquid B, which we've just worked out as 8,400, and then we're going to divide that by the volume. Well, liquid A volume we worked out as 20, and then liquid B volume we were given as 30. And once we put all of that either into a calculator or we work it out ourselves, it's actually non-calculator this, so it's going to be 9,800 divided by 50, which is the same as saying 980 divided by 5, and that's therefore going to give us an answer of 196 kilograms per meter cubed, and that would be the answer to this particular question. Okay, hopefully that's okay for you. Let's move on then to question number 14. Again, if you're not sure, please do let me know. So, question number 14, Sally plays 2 games against Martin. She can either win, draw or lose, and it gives us some probabilities. Okay, so what I'm going to do is I'm actually going to use a probability diagram, a probability tree. Some people don't tend to bother about these things. I just think it's a good discipline to actually do it, and it also allows you then to fill in all the information. So the probability that Sally will win is going to be 0.3, that she will draw is going to be 0.1. I'm just taking this information from this information at the top here, and then the probability that she'll lose therefore is going to be 0.6, because all the probabilities need to add up to 1. And actually I can do exactly the same for all my other, or the second game that she plays against Martin. So I've got win, draw, lose. I've got win, draw or lose, and then finally at the bottom here I've got win, draw or lose. Now all of those are they are independent, but they relate to the probability from the first game that she plays. Okay, so what am I interested in? Well, I'm interested in win, draw, because I'm actually interested in the probability that Sally will win exactly one of the 2 games. So win, draw is important to me. Well, she's going to probability of 0.1 for draw, so therefore I can just multiply this out. 0.3 times 0.1 is going to be 0.03. Okay, so that's probability that she wins the first game and then she draws the second game. Okay, probability that she wins the first game and then she loses the second game. Well, that's going to be a probability of 0.3 again, but this time multiplied by 0.6, which is the probability she loses, and that's going to give us 0.18. Okay, so that's dealt with where she won the first game. Okay, let's have a look at when she wins the second game. Well, there's only one probability in that she draws the first game and then she wins the second game. So that's going to be 0.1 multiplied by 0.3, and that's going to be 0.03. Okay, and then finally she loses the first game and then she wins the second game. So that's one over here, and that's going to be 0.6 multiplied by 0.3, which is going to be equal to 0.18. Okay, so the probability that Sally will win exactly one of the 2 games against Martin is all of these probabilities added up, which is 0.42, and that would be the answer to question number 14. Okay, hopefully that's okay for you. Let's move on then to question number 15. And this is a perpendicular line. Well, a perpendicular line is the negative reciprocal of the gradient of, in this particular case, the straight line L1. So the gradient of L1 is going to be a gradient of 3, which is, I've got that from this bit of information here. Okay, so therefore the gradient of L2, which is the perpendicular, is going to be the negative reciprocal, which is negative 1/3. Okay, and then really it's just a case of, because we've got the points 9, 5, we can actually put these into the general equation of a line, which is y equals mx plus c. So we know the gradient is -1/3, so I can write that as -1/3 x plus c, and we use in the general form y equals mx plus c. These tend to crop up quite a bit, so it's worthwhile getting to grips with these sorts of questions. Okay, so we know that x is 9 and y is 5 on that particular line, so I can write 5 equals -1/3 times x, which is 9, plus c. Okay, and then I can multiply out and I'm going to get 5 equals -1/3 plus c, add 3 to both sides and I get 8 equals c. So therefore in this particular form, which is the form in which they've asked us to put it, or at least they've suggested we put that in that form, it's going to be y equals -1/3 x plus 8, and that would be the answer to question number 15. Okay, let's move on then to question number 16. I'm going to aim for this video to last about 20 to 30 minutes or so, to give you about an hour's worth of fairly focused revision. Okay, this one is a fairly new topic that's actually only been around for a few years now. However, I would say it's not particularly popular, but it is one that is worthwhile being aware of it. It's called, if you are interested, it's called Capture, Recapture. And if you go to my website or to the YouTube channel, there is a playlist on these types of questions. Okay, so work out an estimate for the number of bees in the hive. Well, catch is 90 bees on the Monday, so it's 90 out of the bees that are available in the hive, which is, let's call it X. Okay, so on Tuesday she catches 120 of the bees and finds that 20 of these bees have been marked. So that's therefore 20 out of 120 have been marked, and then really it's just a case of solving for X. So if I cross multiply, I'm going to get 20x equals 90 times 120 is 10,800. And then I'm going to divide through by 20, and again you might need to do a different calculation to me. I would do probably a little bit of division, but I end up with 540 equals X, and therefore an estimate for the total number of bees in the hive is going to be 540 bees. Okay, and then part B of the question, Shirley assumes that none of the marks have rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, in other words, some of the marks have rubbed off, then what effect will that have? Well, if some of the marks have rubbed off, okay, again, please apologise for my, or I apologise for my dreadful writing. So if some of the marks have rubbed off, the answer would be too high. It would be an overestimate. Okay, the answer would be too high, and if you want to put in brackets an overestimate, that would be absolutely fine. Okay, so hopefully that's okay for you for question number 16B. Okay, and that's all about bees in a hive, and it is, as I say, capture, recapture. Okay, let's move on then to question number 17, okay, which is a fairly standard, make F the subject of the formula. The problem you're going to have is we've got an F here and we've got an F here as well, so I need to be mindful of that. So what I'm going to do is I'm firstly going to get rid of the numerator of F minus 4 by multiplying across. I'm going to get D times F minus 4, and that equals 3 times L minus F. Okay, so if I multiply out, then I'm going to get df minus 4d, 4d. Okay, again, apologies for my awful writing. I'm going to get 3l minus 3f. Okay, and then I need to get my f's on one side, so I bring the minus 3f across, and I'm going to get df plus 3f equals, and then I'm going to take the minus 4d out to the other side. I'm going to get 3l plus 4d. Okay, and then really the easiest way of dealing with this is to factorize for f. So I get f brackets d plus 3, and that equals again 3l plus 4d, and then I'm going to divide through by d plus 3, and I get f, which is the subject of the formula, is going to be 3l plus 4d, all divided by d plus 3, and that would be the answer to question number 17. Okay, hopefully that's all right. Let's move on then to question number 18. X is proportional to the root of y, where y is larger than 0. Okay, so let's have a look at that. So if we're saying that x is proportional to the root of y, let's say for a moment that y in this particular case is say 100, it's going to be easier if I'm going to increase by 44%. So therefore x equals the root of 100, so in this particular case then x would equal to 10. Okay, what happens then is that if y is increased by 44%, what I've got is the same idea. I've got x is proportional to the root of y, but now y is equal to 144, so therefore x equals 12. Okay, so therefore what's the percentage increase? Well, it's going to be difference over original multiplied by 100. So if I write percentage increase, and again please do always write these formulas down, difference divided by original multiplied by 100, so the difference is going to be 12 take away 10 is going to be 2, divided by the original of 10, multiplied that by 100, and when you calculate that, it's all going to work out at 20%, and that would be the answer to question number 18. Okay, so I think at this point it's probably not a bad point to finish. The next few questions are going to be quite challenging, so we'll leave it at that particular point, which is the end of question number 18, and then in the next video we'll start from question number 19 onwards.